Now in this section we shall be discussing about the snow and ice sections. Now if we're talking about the snow and ice, both of these are two different terms. They both are, we can say, solid forms of water, but they do have different properties. Ice is basically the solid form of water, and snow is basically ice. I'm repeating here, that is basically the solid form of water, but snow is the form of ice that falls as a frozen water from the sky. And if that water forms the crystals, you get the snow flakes. So we can say that ice is basically solid, smooth, and transparent, while snow that comprises the individual ice crystals. And ice forms when the water freezes, but snow is basically the result of the frozen water vapor in the atmosphere. So snow can be compacted for the traction, but ice is the one that poses a greater risk for accidents due to its slippery nature. So that is the first introduction we can say to understand the difference between the snow and ice. Although snow has been reported over a wide area in Australia, and effects are not always structurally significant. The occurrence of snow in New Zealand is basically greater because of the vast area of the forest, particularly in the South Island. And areas of New Zealand are not subjected to snowfalls that are structurally significant. What I mean here is that in New Zealand, basically in the areas where there is very heavy snowfall, the population is also not that much, or the building density is also not that much. So that is what I'm trying to convey here. Significant snowfall is defined as that which results in the average snow accumulation on the ground of 175 mm or greater, with annual probability of 1 in 150 years. Not all locations above 600 meters in we can say New South Wales, or we can say Australian Capital Territory or Victoria, and above 300 meter in Tasmania, not all locations are subjected to significant snowfall. Typical examples are Canberra and Armidale. Now, icing is assumed to be relevant for alpine regions. However, the formation of ice is highly sensitive to the conditions. Now, you do need to understand 2 to 3 terms here. First, that we already have understood the difference between the snow and ice. After that, the impact. What exactly is the impact of, we can say, the snow or ice on the buildings? Now, we cannot say that the whole of Australia or New Zealand is having the impact of, we can say, snow, unlike Canada. So in Canada, we do know that it snows a lot. So that is the country in which, majority of the buildings, we do need to check for the snow actions. But if we're talking about the Australia and New Zealand, we are talking about the areas where there is no as such, we can say, impact of snow and ice actions in majority of the areas. But we do have some areas where we do need to check or calculate the snow and ice actions. Now the third term that you do need to understand is the difference between the alpine and subalpine region. Now what exactly is the difference in that? Alpine is the region where maximum snow load is usually due to accumulation from a number of successive snowfalls. But in subalpine regions, we can say that maximum snow load is usually due to a single snowfall. Now, in other simple terms, we can say that for areas where we are having where we are there's this very heavy mountains, and we are at a very large altitude above the mean sea level. In those areas, we do have successive snowfalls. So let us say, like, we do have successive snowfalls like 8 to 10 times in winters. So that area shall be classified as alpine region. But we do have some, moderately high areas where the mean altitude above mean sea level is not that high. But still we do have, mountains, and we do have still some possibility of like having snowfall once, or we can say even twice in an year also. That area is classified as subalpine region, and that is a definition, or we can say term, that we shall be using a lot when we are calculating the snow and ice actions. This is basically the map in Australian standard AS1170 for snow loads, and in here we can say that these are the alpine and subalpine regions where snow loads are significant. So you can we can zoom here also to see the areas. So these are the names of the areas where alpine is classified as Kilandra, or we can say Threadbow, or in Victoria it is Falls Creek or Mount Hotham. In Tasmania it is Great Lake area. Or we can say after that, if you're talking about the subalpine region, if you're talking about the New South Wales, we do have this Crookwell, or we can say Orange, or in Tasmania we do have Bothwell or Derwent Bridge. Similarly, we do have this whole list of the subalpine region, and this is the whole list for the alpine region. So this map is basically taken from the Australian standard itself, and this region is basically also showing the hatch also. So this hatch is basically for the alpine, and this hatch, the inclined hatch, this is for the subalpine region. So let us say you do need to design a building in this particular area. We do need to have the subalpine region as the basis to calculate the snow loads. So this is basically the zoomed image of this particular area. So this area is nothing but, we can say, Tasmania itself. So after that, if we're talking about the alpine and subalpine regions, so the broad classification is that if we are talking about the AN region, northern tablelands of New South Wales, the subalpine is at all altitudes above 600 meters. And for we can say region AC, that is center tablelands of New South Wales, subalpine is at all altitudes above 600 meters. Third, categorization is that for AS, these are basically the region AN, AS, AC, and AT. So these are the four regions: region AN, AC, AS, and AT. So these four regions are basically explained here: AN, AC, AS, and AT. Now AT is basically the Tasmania region, the one that we were discussing here. So subalpine region is at, we can say, altitude between 300 meters and 900 meters above mean sea level. Alpine region is classified as a, we can say, region above the height of 9 meter above the mean sea level. So that is for Tasmania. If you're talking about the southern tablelands, that is New South Wales and Victoria, we do have subalpine between 600 meters to 1200 meters, but alpine greater than or equal to 1200 meters. After that, if we're talking about the center tablelands of New South Wales and AN, we do know that we do not have any alpine region. We only have subalpine regions at all altitudes above 600 meters, and here also subalpine at all altitudes above 600 meters. So this you do need to understand. So this is evident from here also. That is, we only have this hatch. We do not have the other hatch here, that is of the alpine region for region AN and AC, and that is evident from A and B also. So I hope this is clear to you that basically Australian standard has categorized 4 different regions, and in these 4 different regions, as per the altitude above the mean sea level, we have classified it as whether it is an alpine region or subalpine region. Why we do need to categorize or divide into alpine and subalpine region? Now the basic point is that the duration of snow loads, that is different when we're talking about the subalpine and subalpine regions. For alpine region, snow may be expected to stay on the roof for significant proportion of the snow season. So if you're talking about a snow season of, let us say, 2 to 3 months, so we can assume that, let us say, this is the building on which we do need to do the structural analysis. So we can assume that this building shall be having the snow load for 2 to 3 months of the winters. So that is why it is different. But for subalpine region, the snow load is usually lasts for few days at max. After that, it usually melts, or the load decreases. So for alpine, we are talking about the 2 to 3 months. For subalpine region, we're talking about the, let us say, 6 to 7 days, not more than that. So after that, we can assume that the load shall be 0 also. Design snow density is also, that is also different. So if we are having, the area for that, or we can say alpine region, the density of the snow is usually in the range of 400 to 500 kg per m meter cube. But for the subalpine region, it is only 250 to 300 kg per meter cube. That is why, it is very important to categorize. Shape coefficients are also different. Now, what exactly we mean by the shape coefficient? Let me just, ask you a simple question. Let us say we are having a different kind of, buildings. First building is having a roof of something like this. Second building is having a roof of something like this. Third building is having a roofing arrangement, something like this. So in this 1, 2 and 3, whether we can say that snow load or behavior shall be same or different. The answer is that snow load, or we can say behavior, that is different. How we can, measure or quantify the snow load on these three different kind of roofing system? The code help us by providing the shape coefficients. So for these three different type of roofing systems, we do have different shape coefficients. On the basis of that, we can calculate the values of the snow loads. So that is why, and additionally, these shape coefficients are different for alpine and subalpine region. And these all values are given in the code itself. So after that, the same categorization, like if you're talking about Australia, we do have categorization of AN, AC, AS and AT. But if we're talking about the New Zealand, we do have categorization or categories as N1, N2, N3, N4 and N5. Now N1 is basically the northern or we can say, sorry, the southern portion of North Island of the New Zealand. So if we want to see the N1 area also, so this is basically the N1 region, and there is no significant snow below the 400 meters. That is why subalpine is between 400 to 1200 meter and alpine is greater than or equal to 1200 meters. Second zone, that is the region N2. This is the region N2. That is this portion and this portion. So subalpine is in here we can say that there is no significant snow below the 200 meters. That is why subalpine is between 200 and 900 meters and alpine is greater than or equal to 900 meters. For region N3, there is no significant snow below 150 meters. So subalpine is between 150 and 900 meters and alpine is between greater than or equal to 900 meters. For region N4 and N5, so we can see here that subalpine is less than 900 meters and alpine is greater than or equal to 900 meters. So that is how, the code has classified the different areas for the calculation of the snow loads. So that was the basic introduction that, we have understood first of all, the difference between the snow and ice. We have understood a difference between the alpine and subalpine region. We have understood that the code has divided the country into various zones. For Australia, it is AN, AC, AS and AT. For New Zealand, it is N1, N2, N3, N4 and N5. And as per the altitudes above the mean sea level, they have categorized various areas into alpine and subalpine regions.